Hello, everyone. This is in continuation to our discussion on the subject Quantitative Techniques of 5th semester BCA NEP syllabus. We were discussing about some important questions and its solutions. This is part A. The first question is, which day of the week was 12th March 1940? So we have to adopt certain steps. Before that, we need to know one thing, that is, we need to remember these things. The last day of 1600 is Sunday. Then the last day of 1700 is 2 days before, that is Friday. The last day of 1800, again 2 days before, it is Wednesday. Then last day of 1900, again 2 days before, Monday. Again, the cycle will come to Sunday, in the sense last day of 2000 will be Sunday. So these days we need to remember to solve the above. Now, there are certain steps we need to follow. First step is to identify the last 2 digits of the year given. So let me write last 2 digits of the given year less 1. That will be 40. 40 is the last 2 digits. We may notice 40 minus 1. So that will be 39. The next step is to find the integer value. Integer value of this 39 divided by 4. 4 means we are trying to find out how many leap years are there in that till before 1940, we can say. So since it is integer value, I am putting a box brackets. So this, if you calculate, we get 9 point something, which means the integer value is 9. Then the next step is to identify number of days in this particular year, that is 1940, number of days in January. We know number of days in January will be 31. Then this 1940 is a leap year. So the number of days in February will be 29. Then in March, 12 days only, because this we are interested in finding out the day of 12th March. So number of days in March is 12. Now we need to add these numbers, that is 39 plus 9, 48, 48 plus 31, 79, 79 plus 41. We get 120. Isn't it? Let me recheck this once again. 39 plus 120. Now we have to find out, the next step is to find out remainder. We get after dividing 120 by 7. We get the remainder as 1. So the 1 denotes Therefore, we can say the required day of this 12th March 1940 is, we know in 1900, the last day is Monday. So Monday plus 1, we get Tuesday. One day we are adding on Monday, which is Tuesday. So that will be the solution for this particular question. Let us move on to the next question. It is a 8-mark question. How many ways the word animation can be arranged such that A, repeated letters, and B, vowels comes together, part C, consonants comes together, part D, vowels never comes together. Repeated letters means, as it is, there are already repeats in the letter. So let me say A, repeated letters are already there in the word animation. So we can directly find out the number of permutations as number of permutations or number of ways is equal to how many letters are there in animation. You may notice there are 4 plus 5, 9 letters are there. So 9 factorial divided by A is repeated twice, so 2 factorial. N is repeated twice, so 2 factorial. I is repeated twice, again 2 factorial. Rest of the letters are repeated only once. So I will write here, since A occurs twice, what is the other one? N occurs twice, and then I occurs twice. All other letters occur once. So on that basis, this is the thing. Now, if we evaluate this, we will get 45,000, or let me do it. No? 9 factorial. Let us do it. So the number of permutations or the number of ways is equal to 9 factorial can be written as 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. I can write it as 2 factorial divided by 2 factorial into 2 factorial into 2 factorial. 1 2 factorial can be cancelled. Now, this is 2 factorial into 2 factorial. 2 into 2, 4. So we can cancel this 4 with this 4. Now, if we multiply 9 into 8 into 7 into 6 into 5 into 3, we will get 45,360 ways. So that will be the first part of the question. Second part, it is about vowels comes together. So we may notice the vowels present are what are the vowels? We have A, then I, then A, then I, then O. So A, I, A, I, O. We will consider all the vowels together as one letter. Say alpha. So that means that is A, I, O is equal to alpha. All the above letters, all the above 5 letters, sorry, all the above 5 letters can be arranged in how many ways? Totally 5 letters. So we will say 5 factorial divided by A is occurring 2 times, I is occurring 2 times. Only AO is occurring once only. So this will become 5 into 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. This and this gets cancelled. 2 factorial is nothing but 2. So that goes with this 2 times. So this is 10 into 3, 30 ways. This is we have done only for this alpha. Now for the full. After considering AIO equal to alpha, the word will have, the original word will have, what are the letters it will have now? It will have N, M, T, N, and then alpha. And again, this can be arranged. The above can be arranged in totally 5 letters, so 5 factorial divided by n is occurring 2 times, so divided by 2 factorial. That is 5 into 4 into 3 into 2 factorial divided by 2 factorial. This goes with this, and this is 5 4s are 20, 20 into 3, 60. So therefore, the total number of ways where vowels come together is equal to, initially we got 30, now we got 60. So 30 into 60, we get 1800 ways. That is the solution for this. The other 2 parts, we will do it in the next video. Thank you.